Okay, very good afternoon, one and all. So in the last class, we have discussed the matrix representation of linear block codes. And even we have discussed some of the problems regarding the linear block codes. In the today's class, we can discuss the syndrome decoding. So the decoding process for linear block codes. Okay. So in the last class, we completed this model of problems, how to solve this kind of problems. So whenever a parity check matrix HR by N is given for a 7,4 linear block code, so whenever H matrix is given, H matrix is of size, already you know it is of size R by N, where R represents. Ma, please mute yourself. So here R is the number of check bits, which is 7 minus 4. So N minus 4. So you will get R as 3. So H is of size R by N. So 3 by 7. So it is P transpose matrix followed by I R by R. So using this you can obtain the generator matrix is as generator matrix is of size N by K by N. Okay, where K is the number of message bits. Here you can see number of message bits are 4. So generator matrix is of size 4 by N. Okay, so already I told you generator matrix is I K by K followed by P K by R. Because K is 4 here, I K by K will be unity matrix, unity diagonal matrix. So identity matrix. Okay, identity matrix. So I 4 by 4 followed by P 4 by 3. So here H matrix is given to you. So P transpose is given followed by I 3 by 3. Now you need to get the generator matrix as I 4 by 4 followed by P K by R. So just take the P transpose of P transpose so that you can get the generator matrix. So which is I 4 by 4 followed by P transpose. Okay. The same problem we discussed in the last class, and I told you that this is very important for your external examinations. And here I told you how to calculate the check bits. So check bits C is equal to message bits followed by M into P. So message sequence follow into parity submatrix P. So this is P transpose. If you take the transpose of this, you will get P matrix. So M into P give the check bits, and minimum distance D minimum will be the minimum code word length. Okay, so minimum distance between the code vectors is the smallest weight out of the code words other than 0. Okay, so like that you can calculate the minimum distance, and even you can see the same in the problems. I told you the same in the last class. Okay, so like this C is equal to M into P, message vector followed by submatrix here you will mention. And upon the, so here we have 3 check bits, so C1, C2, C3, and K is 4, so 4 message bits are there, M1, M2, M3, M4 into P. So P matrix you can obtain by taking the transpose of P transpose. Okay, so if you take the transpose of P transpose, you will get P matrix. So that is represented here. M into P gives our check bit matrix. Okay, so using this relation, you can get 3 equations because here R is 3. So it is M1 XOR M2 XOR M3 because M1 into 1 XOR M2 into 1 XOR M3 into 1 XOR M4 into 0. So you will get M1 M2 XOR M3. So similarly, first this row is multiplied with second column to get C2, and message vector is multiplied with third column to get C3. So M1 XOR M3 XOR M4. So using these three relations, and because the K is equal to 4 message bits are there, we have total of 16 combinations. So for each and every combination, we have to calculate the code words C1, C2, C3. Okay. So for each and every message combination, get the C1, C2, C3. Okay. So for even number of ones, output is 0, and for odd number of ones output is 1. So M1, M2, M3. So if you take the XOR of these three, you will get C1 as 0, C2 as 0, and C3 as 0. Because C2 is M1 XOR, M2 XOR, M4. So like that, for even number of ones present in the corresponding combination, you will get output as 0. And for odd number of ones, you will get the output as 1. So like that, we will calculate C1, C2, C3. And now we have 16 combinations of message bits. So 16 code words we obtained. And each code word, first code word is 7 zeros. So 4 zeros followed by 3 zeros. Second code word is 0001 followed by 011. Because code word is a combination of K message bits followed by R check bits. Now count the number of ones. So in the first code word, so 0 number of ones are there. So weight is 0. In the second code word, weight is 3. So the same 3 we represented. In the third code word, weight is also 3. So 1, 1, 1. So weight is 3. And in the fourth code word, if you observe, weight is 4. So based on the number of ones. Okay. So finally, we can obtain the weight of all the code words. Okay. So minimum distance between the code vectors, if you see the minimum distance other than 0. So d min here minimum value is 3. So we can calculate, we can consider the d min as 3. Now the number of error bits can be obtained as number of error bits detected can be obtained as s plus 1 is less than or equal to d min. Okay. So s is less than or equal to d min minus 1. So d min is 3. So number of error bits that we can detect is less than or equal to 2. And how many error bits we can correct? 1. Because 2t plus 1 is less than or equal to d min. So we'll get t as less than 1. Okay. So like this we can solve the varieties of problems, and this model of problems are very, very important for your examination. So please check here. So I have mentioned in the PPT that these problems are very important for exams. So go through this model of problems. Okay, that problems are available in the PDF. Now let us move to the syndrome decoding. This syndrome decoding, decoding process of linear block codes. So now up till now we studied the code word representation. Till now we studied the code word representation of linear block codes. So using linear block codes, we can generate the code word as message bits followed by check bits. How many message bits? For an n comma k code, k number of message bits are there, and r number of check bits are added. Okay, to form a code word. So k message bits followed by r check bits. Already ikkada cheppam kada mana. So how can you represent this is a code word. So this type of code words, a number of code words are generated by the linear encoding process, linear block encoding process. So this kind of code words are formed in a sequence, and that is passed through the channel. So each code word consists of k message bits followed by r check bits, where r is n minus k. Okay, k is the number of message bits. So like that we finally generated the various code words, and that will be passed through the channel. Okay, very good. That is a good procedure. But at the receiver, you have to you should properly reconstruct or recover the message bits. They can recover the message bits. Okay, so for recovery of the message bits, properly, syndrome decoding process is generally used. Okay, so now let x be the transmitted code vector. So let us go through syndrome decoding for linear block codes. Let x be the transmitted code vector. Okay, and corresponding the received code vector be y. So what is x? X is a transmitted code vector and the received code vector is y. Now, if the received code vector is equal to transmitted code vector, then there is no error. Otherwise, there exists some transmission errors. So if the received code vector is not equal to the transmitted code vector, then there exists some error. Okay. So syndrome decoding is used to detect and correct those errors. Syndrome decoding is used to detect and correct those errors when a received code vector is not equal to the transmitted code vector. Okay, so what is the need of syndrome decoding? So detecting and correcting the bit errors. So syndrome decoding is used to detect and correct those errors. That's used to generate or reconstruct the message bits properly at the receiver section. Okay, now let us go through the properties of syndrome decoder. So what is the need of syndrome decoder? It is used to detect and correct the bit errors that occur when the received code vector is not equal to the transmitted code vector. Now let us move to the properties of syndrome decoder. So already you studied the parity check bit matrix H. I told you H is of size R by N. Matrix H represents the parity check matrix. It is of size R by N. So it is equal to, H is equal to, I told you it is P transpose followed by I R by R. So P transpose followed by I R by R, where R represents the number of check bits and K represents the number of message bits. So this thing you know. Now the first property of syndrome decoder is X into H transpose is equal to 0. What is X? X is the transmitted code vector. So what is, please listen carefully, the properties of syndrome decoder. This is also important for your examination. So list the properties of syndrome decoder enter. So first property is X into H transpose is 0, where H is P transpose followed by I R by R. So what is the matrix size of H? If you see the rows, so how many rows are there? R number of rows are there. How many columns are there? In the first section you have K columns, and second matrix, that is I matrix, you have R columns. So K plus R columns are available here. How many columns are there? K columns for P transpose matrix and R columns for identity matrix. So total rows are R, and how many columns? K columns plus R columns. So you will have n number of columns. So first property is X into H transpose is 0, where H R by N is equal to P transpose followed by I R by R. Now here we want H transpose, not the H. So by using H matrix, that is parity check matrix, we can calculate the transpose of H matrix. So H transpose N by R is equal to, so if parity check matrix is H of size R by N, then H transpose will be of size N by R. H transpose will be of size N by R, because transpose, so if you apply the transpose of a matrix, the rows and columns will be interchanged. So each first row becomes the first column and the first column becomes the first row. Like that, rows and columns will be, row and column locations will be interchanged. So H transpose will be of size N by R. So it is equal to, applying P transpose to P transpose, you will get P. Because P transpose is of size R by K, the transpose of P transpose will be P and size will be K by R. And identity matrix is of size R by R. So as an overall, if you see how many rows are there, K rows plus R rows are there. k rows plus r rows. So total you have n rows. K plus r. So that will be n. How many columns are there? Only r columns are available. So it is of size n by r. Okay. So anyhow H transpose will be n by r. So what is the first property? X into H transpose is 0. Ante entama? The product of transmitted code vector and the transpose of parity check bit matrix is 0. That is the first property of syndrome decoding. So if it does not happen, then there exists some error. So what is the need of syndrome decoding? It is used to identify and correct the bit errors when received code vector is not equal to the transmitted code vector. So what is the first property? The product of transmitted code vector and H transpose is 0. If it is not 0, then there exists some error. So what is the first property? Syndrome decoding. Let the transpose of parity check bit matrix be H transpose. So then the product of transmitted code vector and the transpose of H matrix will be 0. This is the first property. Remember this. And second property is Y into H transpose is also 0. Okay. If Y into H transpose is equal to 0, then it is error-free transmission. If Y into H transpose is equal to 0, then there exists no errors. Remember, first property is X into H transpose is 0, where X represents the transmitted code vector and H transpose is the transpose of parity check bit matrix. It is of size n by r. For example, as a second property, if the product of received code vector and a transpose of parity check matrix is equal to 0, then it is error-free transmission. For example, if Y into H transpose is not equal to 0, then we can say that there exists some error. The first property is X into H transpose is 0. Second property is Y into H transpose should also be 0. Then it is error-free transmission. For example, if Y into H transpose is not equal to 0, then we can say that there exists some error. If it is not 0, we'll have some value. Say yes or no? Yes. If Y into H transpose is not equal to 0, ante enti, there is some value. That value is generally called as syndrome. So what is syndrome? Syndrome is equal to Y into H transpose if it is not equal to 0. So S is equal to Y into H transpose if it is not 0. Okay, if it is 0, we can say that there is error, it's error-free transmission. So directly you can consider the received code vector as a transmitted code vector. Now, what is Y? Y is the received code vector, which is equal to the modulo 2 addition of transmitted code vector and error. Transmitted code vector and error. And Y is equal to X or E, where E represents the error. For example, if there is no error and E is 0 ankodi, then X or 0 will be, what is the value of 1 XOR 0 or 0 XOR 0? So what is the value of X XOR E? So for example, if you replace the error as 0, then 0 XOR 0 will be any one of you. What is the, for example, if X is 1 and E is 0, 1 XOR 0 will be 1 only. For example, consider E as 0. For example, 0 XOR 0 will be 0 only and 1 XOR E will be 1 only. So when for X XOR E, when E is 0, it is equal to X. Okay. So when E is 0, you can say Y is directly equal to X. Otherwise, it is the XOR operation of the transmitted code vector and the error. So Y is equal to X XOR E. So remember this equation. So where E represents the error. If error E is 0, then Y is equal to X. Okay. So first property is X into H transpose is 0. Second property is the product of, so as a statement you should write like the product of transmitted code vector and the transpose of parity check matrix is 0. So second statement is the product of received code vector and the transpose of parity check bit matrix should be 0. It should be 0. Then it is error-free transmission. If it is not 0, there exists some value. That value is considered as a syndrome, or you can say it is defined as a syndrome. Okay. So where Y is equal to X XOR E, where E represents the error. Where E represents the error. Okay, ma, let us move to the next slide so that we can see the third property. So these are the two properties. Now third property is, I told you in the second property that if Y into H transpose is not 0, if it is 0, then there is no issue. Directly you can take the Y as X XOR 0, so you will get X only. But if the Y into H transpose is not 0, there exists some value that is defined as syndrome S. Okay, so S is equal to Y. What is Y? Please replace Y. Y is the received code vector, which is the modulo 2 addition of transmitted code vector and error. So Y is X XOR E. Please replace that into H transpose. So syndrome, what is syndrome? It is Y into H transpose if it is not 0. So X XOR E multiplied by H transpose. Now take the product. So take the product with H transpose. So X into H transpose XOR E into H transpose. Now, so if you multiply with the H transpose, you can split this into two terms. X into H transpose modulo 2 addition with E into H transpose. But from the first property, X into H transpose is 0. So this is from the first property. So this is mandatory property. Always for a transmitted code vector, X into H transpose must be 0. So once it is 0, we can replace this value as 0. If you replace 0 XOR with some value, output is the corresponding value. So S is equal to X into H transpose XOR E into H transpose. But X into H transpose is 0 from the first property. So 0 XOR E into H transpose. E into H transpose. Now E into H transpose XOR 0, it will be E into H transpose. It will be E into H transpose. Therefore, syndrome S is equal to E into H transpose. Therefore, S is equal to E into H transpose. Now we can directly finally we obtain from the third property as S is equal to Y into H transpose. So whenever Y into H transpose is not 0, then it is called as syndrome S. By replacing Y as X XOR E and considering X into H transpose as 0, we'll get 0 XOR E into H transpose. So any value considering modulo 2 addition with 0, 0 XOR any value gives you the same value, that is E into H transpose. So you can do like this. So 0 XOR, if you take this as 0, you will get output as 0. If you take E into H transpose as some 1, you will get output as 1 because 1 XOR 0 is 1 and 0 XOR 0 is 0. So therefore, finally we obtain the syndrome expression as E into H transpose. So from the third property, we can say that syndrome S is equal to E into H transpose. So what are the first three properties? So three properties of syndrome decoder are, first one is X into H transpose is 0, where X is a transmitted code word and Y is a received code word. Okay, and H transpose is the transpose of parity check bit matrix, which is of size R by N. So if you take H transpose, the size will be N by R. The second property is Y into H transpose is 0. Then there exists no error. It is error-free transmission. For example, if it is not 0, that is called as syndrome, where y is x XOR e and e represents the error. Okay. Now from the third property, S is y into H transpose and chepparu manam from the second property. Now you can replace y as x XOR e into H transpose. Upon multiplication and replacing x into H transpose as 0, we can get output as e into H transpose. Therefore, as a conclusion, we obtain the syndrome as E into H transpose. Okay, ma, S is E into H transpose. So these are the properties of syndrome decoder. Okay, now let us move to the syndrome decoder construction. So construction of syndrome decoder. Okay, construction of syndrome decoder for detection and correction of single bit error. For example, in the transmitted code word, if we have single bit error, okay, for single bit error, like a process will be different. For detection and correction of single bit error, syndrome decoder construction is different when compared to the multiple bit errors. Okay, a little bit difference will be there. We can study that. So, syndrome decoder construction for single bit error. Here we will follow 3 steps. First step is, first we should know whether there is error or not. Asla error unda leda annadi meeku teliyali kada. So in order to do that, first you should do if the received code word is y. So take the y and multiply it with H transpose. If it is 0, we can confirm that there is no error. And always for a transmitted code word, x into H transpose must be 0. And if y into H transpose is also 0, then there is no error. You can confirm that. Even in the problems, they can ask you. You will be given with one received code word. 7-bit code word ichestar. Like for example, 4 ones, 3 zeros. One code word will be given. And that multiplied with H transpose should be 0. If it is 0, you can confirm that there is no error. For example, if it is not 0, then we'll call that as the syndrome. Yes. Okay, we'll consider that as some yes, and we'll process further to calculate that error. And we'll remove that error. Detect cheyadame kaadu, and we can correct that error. Okay, what is the first bit? First step. In the first step, so take the received code vector y and calculate the syndrome using that. So S is y into H transpose. Okay, so calculate the syndrome using y into H transpose. That is the first step. And second step is with the obtained syndrome. Okay, we obtained some value S. Go through the lookup table. So you need to construct a lookup table. I will tell you how to construct. Okay, so with the obtained syndrome, go through the lookup table. So you will obtain some syndrome. So go through the lookup table and calculate the error pattern. Calculate the error pattern. Okay, so I will tell this step 2 while going the problems. So step 1 is calculate the syndrome using y into H transpose. And as a second step, using the syndrome, go through the lookup table and calculate the error pattern. So we'll calculate E. So we'll calculate error pattern E. Okay, so syndrome can be calculated. Now, third step, using error pattern E, So because from the lookup table, so from the constructed lookup table, because for example, I will tell you, if there are 7 bits, if the code word is of 7 bit annar, so 7,4 code, if it is given to you, n will be 7. So y consists of 7 bits. So in the 7 bits, if I tell you that it is a single bit error annar ankondi, error can be in the first position, second position, third position, fourth or fifth or sixth or seventh. Because there is only single bit error, because they specified you that there is single bit error. So error can be at any of the 7 positions. Okay, so that can be calculated. That can be calculated using the lookup table and calculate the error pattern. So E will be calculated. So based on the position. Now using the error pattern, the corresponding code vector can be obtained as x is equal to y XOR E. So you have received some code word, but that is not same as x. Now, because you obtained the error pattern E from the second step from the lookup table, you can take the XOR of the received code word which is given in the question y XOR E. E you have calculated from the second step. I will tell how to solve that while doing the problems. Okay. So y XOR E will be our transmitted code vector x. Okay. So this is the general process. So 3 steps are there. So in order to reconstruct the x, our intention is for what is the decoder principle? So decoder principle is to reconstruct the x using the received code vector y. So in the problem you will be given with y. So using y and h will be given to you. You should calculate h transpose. So y into h transpose chestaru, you will get s. Using the syndrome and lookup table, you can calculate the error pattern. And that y XOR E will be the reconstructed transmitter code word x. Okay, these are the 3 steps which are used during syndrome decoding. Okay, whenever there exists a single bit error. Okay, so the 3 steps I have mentioned, the 3 steps what I told you. Now, the 3 steps we have represented in a block diagram. Let us see. So what is y here? So if you remember these 3 steps clearly, you can draw this flow chart. So this flow chart represents the syndrome decoding during single bit error. Okay. So y, what is y? A received code word or received code vector. So it is y1. So it is y1 to yn. So y1 to yn. Okay. And yn is a MSB bit and y1 is a LSB bit. Now we have that received code word. What is the first step? Using received code word y, calculate the syndrome. This is step 1. So already I told you what is step 1. S is equal to y into H transpose. So calculate, yes, that is syndrome. Calculate the syndrome using y into H transpose. This is the first step, where y is y1 to yn, y1, y2 up to so on, yn. Okay. Now, yes, that syndrome calculated using the syndrome, a lookup table will be constructed for representing the error pattern. Okay. So that is the step 2. So step 2 is lookup table construction for error pattern E. So using the syndrome, we will construct a lookup table. One table will be constructed so that you can calculate the error pattern E. Now this error pattern E consists of once again E1 to En bits. N bits untai. Because E is constructed based on ES, the syndrome, and it is constructed based on the Y. So it consists of N bits. So E consists of E1 to En. So so using this E, that is the error pattern E1 to En. Okay, we'll take the XOR of the received code vector with the error pattern which is generated by the step 2, that is from the lookup table. So E1 to En will be generated, and take the XOR of Y and E. You can generate the transmitted code vector. You can generate or you can say you can reconstruct the transmitted code vector X. So transmitted code vector is X, which is obtained as Y XOR E. For example, if E is 0, then there is no issue. Directly X is equal to Y. For example, some error exists, then take the XOR of Y and E to obtain or to recover the transmitter data. Okay. So if you take y1 XOR e1, you will get x1. If you take y2 XOR e2, you will get x2, up to so on. En XOR yn or yn XOR en, you will get xn. So like that, take the XOR of each and every corresponding bit, you can get the corresponding transmitted code vector that range from x1 to xn. Okay, then finally you have reconstructed the transmitted code vector using the received code vector. So decode for the receiver, the input is the data obtained from the channel, that is y, and using this like as we studied in the analog communication, that modulated signal, I can say that this is a modulated signal which is passed through the channel. Okay, like that, this is a sequence of code words, which is the output of encoder that is passed through the channel, and the receiver collects the code vector consisting of n bits. Okay, so this is the sequence consists of multiple number of code words, and each code word has n number of bits. And already I told you each code word is once again a combination of K message bits and R check bits. Okay. Now using this y, first step is syndrome will be calculated by y into H transpose, and using this syndrome will construct the lookup table for representing the error pattern. So this lookup table is different for different examples. So meeku ichina question based cheskoni, so based on the question given, you need to construct the lookup table for each and every question. This will be different. So lookup table is not same for each and every question. Based on the question, you have to construct the lookup table. I will tell you how to construct while telling the problems. Lookup table for error pattern E. Take the so error pattern will be generated E1 to En. Now take the XOR of Y and E. So each and every bit will be take the XOR operation of each and every bit. So y1 XOR e1 will be x1, y2 XOR e2 will be x2, up to so on. Yn XOR en will be xn. So finally we can reconstruct the transmitted code vector using the received code vector and error pattern obtained from the lookup table. Okay, this is the process of syndrome decoder construction. Whenever a single bit error exists. But for example, there are multiple bit errors. For example, there is a during the channel, we cannot expect that there is only single bit error. So there may be multiple bit errors, and during multiple bit errors, the process will be different. Okay. So this process and this process of 3 steps will be for decoder construction for single bit error. Okay. Now let us move to the syndrome decoder construction. Please wait. Let us move to the syndrome decoder construction. Let us move to the syndrome decoder construction for multiple number of bit errors. When transmitted data consists of multiple number of bit errors, then the decoding principle will be somewhat different. Okay. Now, for example, let us assume these are the following steps. Let us move to the first step. Let us assume n suffix c1 be the number of errors due to single bit. That is the case which we studied in the last slide. Let us assume nc1 be the number of errors due to single bit. Okay. And let us assume nc2 be the number of errors due to double bits. And up to so on, n suffix ct be the number of errors due to multiple bits. Then there will be t, let us assume there are t number of bits for correction. Okay, already I told you for linear block codes 2t plus 1 is less than or equal to d min, where t represents the number of bits for correction. So let us assume the same variable, t represents the number of bits for correction. Then n is equal to, what is n? The number of bits present in the code word is represented as 2 power r minus 1. Okay, so where it is always greater than or equal to, because n is the total number of bits present. So it is always greater than or equal to the number of the sum of the number of error bits. Okay, so error bits, so number of error bits value is always less than or equal to total number. So that's the reason that I have considered as n is greater than or equal to sum of all the bit errors. So at a maximum, how many bits there will be error? En. Okay. Otherwise, the bit errors will be always less than or equal to the maximum value. So that's why n is greater than or equal to nc1 plus nc2 plus up to so on nct. Sometimes nct will be 0, nc2 will be 0, nc1 will be 0. Anyhow, n is greater than or equal to the bit errors. That implies, because 2 power r minus 1, because I told you for the Hamming code, n is equal to 2 power r minus 1. Okay, so that implies 2 power r will be, take this 1 to the right hand side. So it will be 1 plus nc1 plus nc2 up to so on plus nct. Now, if you take this series, this is a summation series. So for nc 0 will be 0. 0 bit errors. So 0 number of 0 bit errors. Okay, so you can represent this 1 as some nc0. So 2 power r is equal to 2 power n minus k, because r is the number of check bits, which is represented as the difference between n, that is number of bits in the code word, and k. K ante message bits, number of message bits. So 2 power r is equal to 2 power n minus k. So which is greater than or equal to summation I is equal to 0 to t nci. So just I mentioned as a summation series. Now please to cancel this 2 power, please apply logarithm on both sides. So if you apply logarithm on both sides and log 2 power n minus k. So inside the logarithm, if you have any power value, that you can take as a product outside the logarithm. So n minus k into log 2 base 2, because we have applied log 2 on both sides. So similarly, greater than or equal to right hand side part log 2. So log summation I is equal to 0 to t nci base 2. Now let us divide. So just here log 2 base 2 is 1. Now dividing by n on both sides. So 1 minus, because n by n will be 1. So 1 minus k by n is greater than or equal to 1 by n log summation I is equal to 0 to t nci. Now this relation is used to calculate the number of bit errors. If we have multiple number of bit errors, this relation will be considered for bit detection and bit correction. Okay, so the above equation gives the relation between the number of message bits k, the number of bits present in the code word n, that is the code word length n, and t represents the number of error bits for correction, and r represents the number of check bits. Okay, and finally k by n is the code rate. Already from the starting onwards I am telling you, k by n represents the code rate. Now this process is generally used for multiple number of bit errors. So anyhow you may not get problems from this multiple number of bit errors. You will have possibility to get the problems based on syndrome decoding up to single bit error. Okay, so but my thing is to please remember these 3 steps. S is equal to y into h transpose. Second thing is, using this S, please calculate the error pattern, and once the error pattern is obtained, which is a n bit data, take the modulo to addition of the received code word and E to generate, or you can say to reconstruct the transmitted code vector. Okay, and if it is the multiple number of bit errors, a summation series, you can replace this sum of all the number of errors due to single bit, double bit and multiple bits. we have considered that n is the total number of bits will be always greater than or equal to bit errors. So 2 power r will be greater than or equal to, take this one to the RHS, and you can replace the RHS part as some summation series. NCI, where I represents a variable which range from 0 to t. Upon applying the logarithm, you will get a relation as 1 minus code rate is greater than or equal to 1 by n log summation I equals to 0 to t NCI base 2. Okay. So now this is all about the syndrome decoding construction. Now you can see here I have mentioned. So with this almost all the module 1 is completed, except we have to discuss the problems on syndrome decoding. So now the model of questions you will get in the examination. So you will get this type of questions. Listen, a parity check bit matrix, please wait. A parity check bit matrix of size 3 by 7 is given as. So 3 by 7 H matrix will be given to you. So it is of size 3 by 7. And H size into general R by N. Here R is 3. So if you see 7, 4 code, this is in the form of N, K. So number of check bits will be 3. So H is of size 3 by 7. Okay, well and good. Now calculate the syndrome vector for single bit errors. Calculate the syndrome vector for single bit error. So for single bit error, first you should remember that there are 3 steps. So 3 steps untayani gurtupeట్టుకోవాలి. What are the 3 steps? First calculate S using Y into H transpose. Okay, so Y into H transpose. So using that you can calculate the syndrome. But here did they give any received code vector? Oksaరి chudandi amma problem. So did they provide you any received code vector? No. But from the property 3, what is the third property? From the property 3, S is equal to either YH transpose or EH transpose. You can write S as either Y into H transpose or E into H transpose. Okay. So here, because the received code vector Y is not given, you can consider the error generic lookup table. Okay. So like in general, the error location can be in the first position or second position or third position or fourth, fifth, sixth, seventh, because it is a 7-bit data, because N is 7 here. Okay, so code word size is 7. So error bit location can be either at the first, second or third or fourth or fifth or sixth or seventh positions. So based on that error position, I have calculated the syndrome as S is equal to E into H transpose. I told you how to get H transpose using H. So H matrix is given to you. How can you get H transpose? Can any one of you tell me how can we get H transpose using H matrix? Any one of you?
We have to just interchange columns.
Just very good, very good. Just interchange the rows and columns. Here, first row is 1101 So that will become the first column. Similarly, second row becomes the second column. Third row will become the third column. So finally, we will get 7 by 3. So you may get a doubt. Can I take first row as first column as first row? Yes, you can take. First column you can consider as first row, that is 111. Second column 1110 becomes second row here, and third column will become third row. Fourth column will become fourth row. Fifth column will become fifth row. Sixth column will become sixth row, and seventh will become seventh column will become seventh row. Okay, like that you will get H transpose. And what is the first step here? First step is E into H transpose. So take the error location, consider it as a first position, and multiply this E with H transpose. So during multiplication ela cheyalamma, take the whole row and multiply with the first column to get the first bit. Ante 1 into 1. So 1 XOR, don't take the normal addition, take the modulo 2 addition. XOR 0 into 1, that will be 0. XOR 0 into 0, that will be 0. XOR 0 into 1, that will be 0. XOR 0 into 1, that will be 0, because 0 into 1, 0. XOR 0 into 0, that will be 0. XOR 0 into 0, so that will be 0. So finally we get 1 XOR all zeros. So if we have odd number of ones, what is the XOR operation? Output is 1. If we have even number of ones or zero number of ones, the corresponding bit will be 0. So alane, if you take the product of first this row with the second column, you will get the second bit as 1 XOR 0 0 like this. So finally third one will be this row multiplied with the third column. So you will get the third bit as 1. So similarly, the lookup table is constructed for all the error bit locations. Okay? Using second error bit location, we will get the syndrome as 1110. Third 011. Fourth 101. Fifth 100. Sixth 010. If you multiply this E with H transpose, you will get 010. If you multiply this 0000001 with H transpose, you will get 001. Because 1 is in the last position. So last position lo undi ante you will get 001. If the error bit is in the 6th position, you will get 010. Please observe the like lookup table carefully and see. Error bit first position lo undi ante you will get first row elements directly 111. If the error bit location is in the second annaru ante from MSB, it will be 1110. If it is in the third location ante third row ostundamma meeku 011 of H transpose 011. So similarly fourth position ante fourth row 101. So like that you will get. And similarly fifth position multiplied by this H transpose, you will get fifth row ante 100. So you can cross verify that doing like this S1. So similarly you can calculate up to S7. So where S7 is 0001, 00001 multiplied by this H transpose gives you the 7th row elements. That is 001. So even meeku, for example, meeku idantha chese time lekappoina, for example, if you have no time to do all these things, directly you can analyze if you have a single bit error and if you know the corresponding position. Ippudu meeku 5th position annaru angane meeku gurtu ravali enti 5th row will be the syndrome. 5th row ఏంటి ఇక్కడ మనకి 100. For example, ఎందుకని this is a single bit error. They mentioned you that is a single bit error that can be of any locations. So for example, 4th location అన్నారు అంటే take the H transpose and take the 4th row. For example, in the objective bits, I may ask you, for example, if the H transpose is given to you and H ఇచ్చేస్తారు exam లో and H transpose you need to calculate. For example, if the error bit is in the 5th position అన్నారు అనుకోండి, if it is objective, directly you can write it as 100. Syndrome S is, if you multiply E will be 4 zeros 100. If you multiply that with H transpose, you will get 4th element, that is 101. 5th location lo unte 5th row ostundi. 6th location aithe 6th row, 7th location aithe 7th row. Like that you can construct this kind of lookup table by using the second step. So meeku first step S is equal to Y into H transpose, but here received code vector is not given to you. But meeku error location, that's your wish, you can consider it in any location. Okay, so based on the locations you can calculate the S. Okay, so S final ga calculate చేస్తారు. Okay, S calculate చేసిన తర్వాత ఏం చేయాలమ్మా? ఇక్కడ మీ క్వశ్చన్ ఏంటి? Calculate the syndrome అన్నారు. Okay, so finally we calculated the syndrome for all the error bit locations starting from first location to 7th location. So calculate the syndrome vector for single bit errors. Okay ma? So like this you can solve this model of problems. అండ్ ఇక్కడే చూడండి ఈ క్వశ్చన్ లో రిసీవ్డ్ కోడ్ వెక్టర్ ఇచ్చారు. Okay, anyhow we can continue the problems in the next class and we can start the second module in the next class. Okay, with this first module is completed. So you can see that you completed the matrix description of linear block codes and its error detection capabilities and error correction capabilities and syndrome decoding. Actually in your syllabus they did not mention properly, but syndrome decoding is also important for your examinations. You will get various problems and they may ask you the properties of syndrome decoding. Okay, so if you have any doubts you can ask, and I will upload the module 1 in your Teams app. So you can go through the Teams app, that's